Hello, everybody. Let's do number one together. First thing is go to your spreadsheet and make a tab called number one, or hashtag one, as the kids are saying. Once you've done that, I'm going to assume that you have read this paragraph right here. If you haven't, pause the video and read it. Otherwise, here we go. Question is asking us about the proportion of students at BHHS that have undergone surgery. That's the only variable that's mentioned. So I'm going to go to the data. I'm going to find the surgery column, which is U. I'm going to copy those data, and I'm going to paste it here into the first column. Now, the next thing we need to do is figure out which test we're running. The problem asks us to compare these data to the national percentage, which is 20. So let's look here. We have our four different tests. And I know that we only have one column of data, which means it's going to be one of these two orange groups here, either the one sample Z for a proportion or the chi-square goodness of fit test. I also know that it's got to be this one right here because we were only given a single proportion, the 20%, whereas a chi-square, you're given multiple proportions. So I am actually, just to make my life a little bit easier, going to copy the conditions and the test statistic. Let me do that. Try it again. I'm going to copy those. And I am going to paste them right here for reference. You're not required to do that. I just think it makes my life easier. All right, so let's see. We know that this is a 1 proportion Z test. We also know that our null hypothesis is that the proportion is the same as the national proportion that had surgery, which is 20%. And that our alternative hypothesis is that at BHHS, that proportion is higher. Okay, let's assume for all of these, the alpha is going to be equal to 0.05. You're going to be turning in this spreadsheet as your work, so you are welcome to copy things down as we move along. All right, so that's like step number one on our phases, right? Step number two is to identify what kind of study this is. This is a population survey. They are all, what happened? Why won't you type? There we go. Everything we do today is going to be a population survey. The other things that we are going to need are, we're going to need the sample size. And then we're going to use that to find p hat. While we're at it, I know that we're also going to need p. I'm looking right here, right? P hat, p, and n. Those are the components that tell our story. All right, so how do we want to go about doing this? You got a couple options. Here's what I'm going to choose to do. I'm a big fan of pivot tables. So I am going to highlight the data that I'm working with. I'm going to go up here and I am going to create a pivot table. I'm going to do it right here on this sheet. It doesn't matter really where I put it. I'll put it right here. Okay, and create. And then let's see. I want my rows to be, have you ever undergone surgery? So it's going to look like this. Options are yes or no. And then if you just go down to values and you say, have I ever undergone surgery? It's going to give you the counts. So 25 yeses, 46 nos. Right, so that tells us that our p hat is, or that our sample size is 71. Our p hat is going to be equal to the yeses divided by the 71. And we know that our p is what we get from the hypotheses. So that's going to be 0.2. All right, so you've got that. That's like phase 2. Phase 3, I want you to tell me about the sampling distribution. Okay, so the center is 0.2. I guess that's sort of repetitive that I wrote it here and then I wrote it again. The standard deviation, or the spread, is going to be equal to this formula here. So we're going to go square root of p times 1 minus p divided by the sample size, and parentheses. So there's your standard deviation. Now for the shape, for the shape, we want to check whether it is normal, and the conditions for normality are right here. N times P and N times 1 minus P both have to be equal to 10. So I'm just going to do a quick check of N times P and N times 1 minus P. And let's see what happens here. N times P is 14.2. We're good to go. And N times 1 minus P is 6. So we can conclude that it is going to be normal. All right, so we've got our distribution. Let's keep going. The next thing we need is our z-score, or our test statistic. And this says that we want to take p hat, subtract p, and then divide by the standard deviation. So I'm going to go parentheses. Oh, do not forget those parentheses, ladies and gentlemen. P hat minus p. You can see that we're about 15% above the national average there, right? Divided by standard deviation gives us, ba-boom, 3.2. Now, the last piece of the puzzle is we need our p-value. And our p-value is going to be a right tail because we're doing greater than. So remember that for a right tail, you do 1 minus norm.s.fist of our z-score, which is going to give us 0.00067. Conclusion, I reject the null hypothesis because the p-value is smaller than our alpha of 0.05. Did I write our alpha in? I did. Okay. There is sufficient evidence to conclude that BHHS students have surgery at a higher rate than the national average for teenagers. Which kind of makes sense, right? We know that we live in a more affluent community, and the more money you have, the more likely you are to be able to afford to have surgery. So it kind of stands to reason, right? All right, there's the problem.